solving equations involving angles and two pairs of parallel lines. So in the last video I made, which was called, where are we? Solving equations involving angles and a pair, oh, nope, that's this one, sorry. Identifying corresponding and alternate angles, and then also finding angle measures given two parallel lines cut by a transversal. So there's a couple other videos. There's one other one. I'm missing the name of it right now. But there's 3 different videos where we've been dealing with parallel lines and a transversal. So in this case, we're dealing with 2 parallel lines, or 2 pairs of parallel lines. So in this example, it says in the figure below, line K is parallel. That's what this little symbol means. It's squished together, but it's 2 tall lines. Is parallel with L. So I have, oh, and look at that. They forgot to label K and L. So K and L are actually on the side here. They just forgot their little label. So there should be a little K and a little L here. And then it also says, and M is parallel to N. Find the values of Z and Y. So here's line M and here's line N. So we have 2 parallel lines this way and we have 2 parallel lines going this way. So it's just 2 pairs of parallel lines. So we still get to use all the same rules that we've had before. Now it just means that we have quite a few more options to jump around in this figure. So if you notice, I already have some notes written here. These were the notes from the last video I did that was about, it was just a pair of parallel lines and 1 transversal. So now we have 2 pairs of parallel lines, but again, same rules. So the first thing we wrote down was vertical angles are congruent. So vertical angles, and I just noticed my E is really ugly on this one, so I wanted to fix it. Should be an E here. So vertical angles do not require parallel lines, but they always come up. So anytime you have 2 lines crossed like this, I'm going to draw my arrows, you have vertical angles come up, because a vertical angle just means that I'm crossing over the vertex like this. So this angle is congruent to this angle. So vertical angles, anytime you have a crisscross like that, you just go across the vertex like this, and I have this angle is congruent to this angle. So I can find vertical angles anytime I have 2 lines. I don't need parallel lines for this one, but it is a very convenient and easy property to apply. The second one we wrote down was a linear pair. So a linear pair, and they add up to 180 degrees. The reason for that is if I have a line here, a line, if I go all the way like this is 180 degrees. Okay. So if I have a line and then I add an angle, or I kind of cut it into 2 angles, I still have a 180 degree line here. So if I add these 2 angles together, didn't mean to erase that line. So if I have angle 1 and 2 and I add them together, angle 1 plus angle 2, they have to add up to 180 degrees because they are on a line. And that's all linear pair means. Linear meaning line, pair means 2. So 2 angles on the line together, or they kind of take up the whole line. That's another way to think of that. All right, let me get on that one off of there. So we also talked about corresponding angles. And corresponding angles are always congruent as long as you have parallel lines. So in order for corresponding angles to work with this relationship, they have to be parallel. So corresponding angles just refers to the position where they are. And you want to be able to describe them in the same way. So I'm going to do one transversal here just so we can see. So I have my parallel lines going from left to right, and I have this transversal going from kind of top to bottom diagonally. Corresponding angles are congruent and they have to be in the same position. So what I mean is if I look at this angle, I'm going to look at the parallel line. It's on top of the parallel line and it's to the right of the transversal. So I want to be able to do the exact same thing to find the corresponding angle. So I want to go to the other parallel line. I'm going to come down here and I'm going to go above the parallel line and to the right of the transversal. So that is this angle right here. So I want to be able to describe it in the same way. It's on top of the parallel line, whichever parallel line I'm talking about. So there's always 2 of them. And it's going to be to the same side of the transversal. So if I come to this side and I look at this angle, then I'm still on top of the parallel line, so this top parallel line, but now I'm to the left of the transversal. So I want to be able to describe the same way. So if I come down to the other parallel line, I want to make sure I'm on top of the parallel line and I'm to the left of the transversal. So it's this angle here. So it's just making sure you can describe them in the same way. So I'm going to, whoops, I'm going to erase this a little quicker so I don't have to undo a bunch of times. All right. And then we also had same side interior angles. And I had added this one once we were working on this. And so I added another color. And if you notice, it's pointing at this sentence here, meaning that it has the same relationship. So same side interior angles also add up to 180 degrees. Doesn't mean that they're necessarily linear pairs, but it's actually related to linear pairs. So if I redraw and now my parallel lines are going up and down and I have this one transversal going like this. So here are my parallel lines going up and down. So same side refers to the transversal. So this transversal, since it's going from left to right, it has a top and it has a bottom, like this. So same side means that the angles have to either both be on the top of that line or they both have to be on the bottom of the line. Interior refers to the parallel lines. So interior means that it's in between the lines like this. So down here, this is also interior because the lines go like this. So anything in between these lines. Exterior means that it's not in between. So it's out here. So this is exterior. This is exterior, exterior, exterior. So all these areas are exterior because if I talk about the lines, like if my hands are the lines and it's outside of the, like on the back side of my hands, I can't squash it in between, right? That means that it's outside, it's exterior. Interior means it's in between the two lines. So these are all interior angles here. And then these are all exterior angles here, like this. Okay, so I've added too many lines here. I think that's going to get a little confusing. So I just wanted to make sure we understood what interior and exterior meant. So if it's same side interior, we now know how to describe it. These are also sometimes called consecutive interior angles instead of same side. Same side is just a little more descriptive. That's why I'm using it. So if I want them to be on the same side of the transversal, I'm going to pick the top. And I also want them to be inside. So here's the top of the transversal. This is inside. The only two angles I have are right here. So these two angles have to add up to 180 degrees, just like a linear pair has to add up to 180 degrees. And they're actually directly related to each other. I did talk about this relationship in one of the other videos, but it has to do with using linear pairs and then noticing this property of same side interior angles. I want to make sure, do they add anything else in here? I think those are the main ones that we're going to need to use here. We're going to kind of jump around the problem using those ones. All right, so now we've re-described all of these. We're going to go ahead and jump into a problem here. Okay, and again, if you're not writing notes, you definitely should be writing notes. You should be adding to the notes each time. And I know I have a very minimal notes here, but that's because of the space I have to write. I can't simply just move this around too terribly much and just keep the page around. So I minimize my notes for the screen, but you should be writing notes down to make sure you understand what's going on. And when I draw a little diagram, you can draw a little diagram by vertical angles. You can draw a diagram by corresponding angles. So you can draw all of these things. I just don't have room to keep them here. All right, so in the figure below, K is parallel to L, and again, they forgot K and L. So this is line K and L down here. And then line M and N are also parallel. Find the values of Y and Z. All right, so we're going to have to jump around just a little bit in order to figure this one out. So first, what I want to notice, let's see. So I'm going to draw. Oh, why am I not going to draw? There we go. Don't know why I wasn't drawing for a second. All right, so I'm going to kind of draw this shape here so that I can show you the jumps that I'm making a little bit. What we always kind of want to start with is the full angle they gave us. So we want to see what we can do with the 62 degrees. So we have 62 degrees here. We have Y degrees here. And we have 5Z minus 108 degrees in here. So first we want to see what can we really do with this 62. So I'm going to go with this one. I know if I use vertical angles, this is one of the easiest ones to use. I know I can jump this 62 over here. So this angle right here is 62 degrees, not the 5Z. The 5Z goes over here to this angle. The 62 I'm talking about is right here, this angle. So the vertical angle, I know that that's 62. Sorry, I had to scrunch 62 in there. I can also do that same thing with this Y. I know I can bring this one in here, and this is also going to be the same. Whatever Y is, this angle will be the same. So now I've kind of brought them all into this square, it's more of a parallelogram over here on the screen. So theirs is much more of a parallelogram. But now what I've done is the very last thing we were talking about on the example page is this same side interior angles, because I brought Y and Z both to the inside of the parallel lines. And then I also brought them both to the top of this line here, which we're treating like a transversal. So the parallel lines I'm focusing on are the two that are going up and down. And then any other line that I look at would be considered a transversal for just the moment. So if I'm looking at the two parallel lines that are going like this, one of the parallel lines going up and down would actually become a transversal. So those titles can kind of move around how you need them to move around. So if I'm looking at the two parallel lines going up and down, then this bottom green line is the transversal when we're talking about same side. So they're both on top of that line and they're both inside. So I know that Y plus 62 has to equal 180 degrees if I add them together. So all I have to do is simply subtract 62 from each side to figure out what Y has to be. So Y has to be, let's go through and do our borrowing here. Y has to be 118 degrees. So we know what Y is. So I'm going to go ahead and type in, 118. Okay. Now that we know what Y is, we can use the same side interior angles again for 5Z minus 180, because now I'm going to switch. This is now my transversal, and now I'm looking at the parallel lines going this way. So now 5Z minus 108 and Y are both inside the parallel lines, and they're both to the right of that transversal. So again, you have to be able to manipulate that a little bit and move things around. But you're only ever focusing on two parallel lines. Even though there's two pairs, you're only focusing on two of them, and then whatever other line that you're looking at would be your transversal. So in this case, I'm going to flip to this one to be my transversal now. And instead of Y, I know that Y equals 118. So I know if I have 118 plus 5Z minus 108, if I add these two together, they have to total 180. They have to add up to 180. So first, let's combine some like terms here. So we have 108, negative 108, and we have positive 118. So if I add these two together, I'm going to have 10 plus 5Z equals 180. Now I can start solving this. So I start trying to get everything away from Z. First, I look at addition and subtraction. Be careful. I know there's a plus sign here, but all that's telling you is it's a positive 5 times Z. Doesn't mean that 5 is being added to Z. It's being multiplied. What's actually being added on the side of the Z is the 10. There isn't a plus sign in front of it, but it's positive 10, which means it's being added. Remember, positive and addition mean the same thing. It just depends on how we say it in the problem. So if I said positive 10 plus 5Z, the positive isn't necessary. I can just say 10 plus 5Z, and everybody assumes that it's a positive 10. It's just one of those assumptions we make through math. All right, so I'm going to subtract 10 from the left, and as you noticed, I also subtracted it from the right. And by left and right, I mean left and right of this equal sign. All right, so we're going to go 10 minus 10. That crosses out just like we wanted it to. 5Z drops down here, and we have equals 180 minus 10 gets us 170. And I do apologize. I'm running out of room here, so I'm going to move this over and see if I can get this written over here. Let's see. You know what? I'm going to flip this. doing right. So, all right, I just want to flip that over so that I had a little bit more room on this side. So I have 5z equals 170. So I'm just rewriting this one up here so I have more room. So our last step is to divide by 5 because 5z means 5 times z. To undo multiplication, I have to divide. 5 divided by 5, or any number divided by itself, is 1. So I'm left with just the variable z, equals 170 divided by 5. Let's see, we get 3 and then 4, I believe. And we can always check that on a calculator. For whatever reason, the calculator's marked off here, so I don't know why they cross off some of them, but you're always welcome to have another calculator open, just like I do here, just to confirm. So we do, in fact, get 34. We have 34 here, and we're going to click check. So these ones are a little bit longer. We do need to jump around a little bit, and you might have to play with it. The way I did it is not the only way to complete this problem. There are other ways to complete it. So it's just one of those problems where you get to play around with it. For example, I jumped around and I did same side a couple of times. But if I brought 62 here for vertical angles, and then I only focus on this parallelogram here, if we go back to the rules of parallelogram, which I know was a few weeks ago, but the rules of parallelogram tell us that opposite sides of a parallel or opposite angles are congruent. So I already know that 5z minus 108 had to equal 62, and I could have solved that. So that's another option for us there, just to move forward. And we don't always have to use the exact same method I used. If you see another method, you can go ahead and move forward, as long as you're applying the rules of parallel lines and transversals correctly. It will work out. All right, let's go ahead and go to the next one. I'm going to move this back over here real quick. And I'm going to erase just my problems. Or just my work. Okay, so this one says, and let's see, what color am I on right now? We'll go to orange. We haven't done orange in a while on these videos. All right, so we have, here's my drawing. And I know my drawing is not terribly great, but I do suggest drawing it because it's easy enough to fill this in, and then you don't have to try to remember on the screen what equals what amount, or remember that, oh, these were vertical angles or something like that. You can just simply mark it, so you don't have to remember these things. All right, so I do know, which I just kind of said, these are vertical angles here. But we want to be careful with that because this is a Z, not a 2. I know it looks like I wrote a Z. Oh, you know what? That Z I wrote in kind of the wrong spot there. The Z should be up top, like that. So instead of starting with vertical angles, because when I wrote this, I just looked at the diagram, I was thinking I wrote Z down here. So we want to be careful with that, though, even if they were vertical angles, because you wouldn't want to write Z equals 5x minus 6. Well, Z and x are in the same equation. I can't solve for that. So we only want one variable when we're going to solve. Let's see if we want to work some of this out in pink. All right. So we did do same side interior angles a couple of times on the last one. So if we look at 66 and Z, they if we look at the parallel lines that are straight up and down, I know we have parallel lines going straight up and down. We have parallel lines going left and right. I'm going to look at the parallel lines going straight up and down because that means that 66 and Z are in between those two. And also, if I'm looking at those as the parallel lines, then this becomes a transversal for a moment. So if they're in between the lines and looking at that transversal, they're both on the bottom of that transversal, then they're on the same side of the transversal and they're interior. So that is the definition of, what is it doing here? It's getting rid of some of my other stuff. So I know same side interior angles add up to 180 degrees. We've already talked about that and we used it twice on the last one. So if I know they add up to 180 degrees and I know I have 66, I can simply subtract. And on the last one, I put it in an equation where I actually wrote 66 plus Z equals 180. I would still end up subtracting here, just like this. So either way, I end up subtracting 66 from it. So if you know they add up to 180 degrees and you have a piece of the 180, because 66 is a piece of the whole 180, I can just subtract it to see what's left over. So I have 10, 4, 1, 1. So I know Z, and I'm going to go ahead and put that in here, Z has to be 114 degrees. And if you notice, they put Z first, and I believe they do that suggesting that you should find Z before X. I don't know if that's 100% true, but it seems like they're suggesting that we find Z first because it's the easier one to find. Okay, so we want to find X now, and let's see. Ooh, this is one that we actually have not written down yet. So I think, let's see if I can get it to fit in between here. So I'm going to talk about alternate interior angles. And they are also congruent as long as you have parallel lines. So in this case, if you don't have parallel lines, which we did have on, I think, a couple of the videos that we made where we were just practicing the names, then they're not congruent. But as long as you have parallel lines, they are, in fact, congruent. So alternate refers to the transversal, just like same side refer to the transversal. So when we hear same side or the word alternate, we're talking about the transversal. So if I draw this as a green line, I want you to think of this as the transversal for just a moment. So that means these two going left and right become my parallel lines. Those are the two I'm focusing on. They're both parallel still, but I'm just focusing on these two going left and right. So I have my alternate, my transversal and my parallel lines. So alternate refers to the side of the transversal. So in this case, since it's going up and down, it's either going to be on the left side or the right side. And in order for this to work, one has to be on the left, one has to be on the right. So that's why they're called alternate. Interior means that they are on the same side of the line. And I just realized that I drew this in the wrong spot. So I want to move this really quick because I put this one down here and I was looking over at the diagram. It should be right in here. This is why I'm trying to use this one, x minus 6, like this. So it should be right here for this angle here. So we want them to be interior, which is why I needed to move that because I accidentally put it on the outside there. But I wanted to be in between my two parallel lines that I'm looking at. So it's in between the two parallel lines. And then we want it to be alternate. So alternate means this is on the left side of the transversal. This one is on the right side of the transversal. So that's all alternate means. One is on the left, one is on the right. If your transversal is going this way, then one would be on the top and one would be on the bottom. So once we identify alternate, so one's on the left, one's on the right, and they're both interior, like this, then we can say that they are equal to each other. And if we know that Z, I didn't write this out, but Z equals 114, we already know that, we put it in our equation over here, then I can say Z, which is 114, equals 5x minus 6, because alternate interior angles are congruent, which means they equal each other. All right, so then I can solve for this one by getting x by itself. So the first thing I want to do is move this 6 to the other side here. It's minus 6, so I'm going to undo that with addition. So I have 114 plus 6, which is 120. And that's going to equal 5x because that just gets dropped down. I didn't do anything with it. Negative 6 plus 6 is 0, which is what we wanted to happen with that. All right, the last step here is to undo the multiplication. 5x means 5 times x. So you undo the multiplication here, and you get 120 divided by 5. Which we would have, I believe, 24. Equals 5 divided by 5, crosses out. So if we have a number minus itself, so negative 6 plus 6, the same number, one's positive, one's negative, they become 0. But if it's a number divided by itself, it becomes 1. And then the x just drops down. And I probably did have enough room to actually write that down below here. I was writing it to the side because I didn't think I had enough room. So the 24 dropped from here, the x drops down from here like this. So x is 24. Go ahead and check that. Yay. All right, one more. Let's make this just a little bigger so that it doesn't take me quite as long to erase this. Couple seconds here of me erasing. Oh no! I went a little too crazy there and erased some of the definition. Ah, little eraser drives me a little crazy. Okay. So I'm going to switch over to the pen. We're going to do one more of these and then another topic down. All right. So I'm going to go ahead and draw this out. Again, drawing it out just makes it a little easier so you can mark it up the way you need to mark it up. Just make sure you're paying attention because I did put things in the wrong spot on the last one. So you want to make sure you're putting them in the correct spot, or you may work it out correctly based on how you put it in the diagram, but that doesn't mean the answer is correct because you didn't draw the diagram correctly. Okay, so there's a couple options we can do here. One of the easy ones is that very first thing I have written up there in blue. We can do vertical angles. So if we do this, then 77 comes in here like this to this angle here. It's not going all the way over here to the 4x. And then z can come in here, again, vertical angles. So we know vertical angles are congruent, so I can just bring them inside like that. So now that I've brought them inside, I have interior. And if I think of, I'm going to change my color real quick. So same side, meaning they're on, or interior, meaning they're inside the parallel lines, and I'm looking at the ones going left and right. And then I drew that pink so that you could remember that is now my transversal. So we always have two parallel lines and we always have one transversal. That's how these work. So I'm on the same side of the transversal. They're both on the right side, and I'm in between or inside my parallel lines. So I know that 77 plus z equal 180. So I'm going to subtract 77 so that I can find my z here. So I end up with 103 degrees. So z is 103 degrees. And if you notice, again, they put z here first. I believe that is their suggestion for figure out z first and then figure out x. Because x, you need z to figure out x. Let's go with gray. We haven't done gray in a little bit here. All right. So now that we know z is 103 degrees, we can do same side interior again. This time, and I'm going to draw this line first. So this time, z and 4x minus 23 are in between the parallel lines going up and down. So those are both in between these two lines, which means we need a transversal. And so that's why I drew that gray line. The transversal is now the one going from side to side like this. So we have two parallel lines and our transversal. So they're both in between the parallel lines, and they're both on the bottom of this gray line that I just drew in here. So that makes them same side interior angles. So we have z plus 4x minus 23 equals 180. Remember, with same side interior angles, you have to add the two together. So this is z. Sorry, I'll put the little cross on there so you know that's a z. Z is one angle, 4x minus 23 was the other angle. I'm adding them together to get 180 degrees. And now one thing I do want to change really quick, because we know what z is. So instead of writing z, because I don't want z and x in the same problem, I can't solve that. I want to change this to 103. Whoop, not 130. 103 degrees, like this. I have 103 plus 4x minus 23 equals 180. Now that I only have one variable, I can solve this equation. So first, I'm going to start by combining my like terms here. I have 103 and I have negative 23. So if I do that, I get 80 plus 4x equals 180. Now I can start getting x by itself by first undoing subtraction. So I have 80 minus 80, that's 0. 4x is going to drop down. Equals 180 minus 80 gives us 100. Our last step is to undo the multiplication here. 4 times x with division. 4 divided by 4 is 1, not 0, 1. And then we bring down the x, equals 100 divided by 4 is 25. All right, so let's make sure we're good. Yay, we're golden. All right.